My name is Felipe Hoffa. As he said, I'm from Chile. I will speak today in English anyway, because even if we are in Spain, we want to do this conference in English. I come from the cloud, from the Google Cloud platform teams. I work in San Francisco. I work very closely to the BigQuery engineering team. They are based in Seattle. And my job here, my job at Google is to, I'm in developer relations. My job is to relate to developers, talk to them. I'm an engineer, I do software projects, I speak code, not marketing. And today I want to share some of the Google Cloud Platform tools, specifically BigQuery. I don't know how many of you were here last year. Last year? Okay, a lot of new people. So the ones that were here last year probably saw Jordan Stigani talk. He's one of the lead software engineers for BigQuery. And I don't want to repeat what he said. I want to build on what he did. But given that not everyone here was there, let me do this first. Previously on BigDataSpain 2012, this is Jordan Tigani. He was here. It was a smaller stage, but he presented this, crunching data with BigQuery. And he introduced the ones of you that were there or the ones of you that have seen that video. Check it out if you want. What is BigQuery? First, as all these talks start, he started with numbers. What is big data? I hope that after a day of being in this seminar, you already know what big data is. If you have questions, we can talk about that later. And he introduced an important piece of Google technology. That's Dremel. Dremel is a technology, a paper that we released a couple of years ago that allows you to analyze terabytes of data, like really big pieces of data in very few seconds. It's really impressive. To start, he gave a demo. In this case, he's running a regular expression over terabytes. No, this is not terabytes. This is 600 gigabytes of data. People were really impressed of how fast we did that query. I measured it yesterday, it was 18 seconds. I don't know if people have tried doing regular expressions on this amount of data, but usually it takes much longer. How does this work? This is architecture of Dremel. Not to repeat him, but so we have the distributed storage, that's all in RAM. Instead of using indexes, all the analysis is done over full table scans, and instead of having an index tree, we have a computing tree. A tree of servers take the data, the leaves filter them, and it gets passed upstream at extremely fast rate in a parallel way. He did a demo. I think people were really impressed. Someone remembers it? Yes, thank you. And of course, he went much deeper. Some important things you should remember is how to upload data to BigQuery. You usually take a JSON or a CSV and upload it. It's an API. I will show you later. It's web UI that makes it very easy to use. But the power comes from being able to connect it to your software. It has a REST API if you want to connect it to other software. A lot of people do, like, for example, you can connect it to spreadsheets or to visualization software like Vimeo, like Tableau, and a whole lot of partners we have. And of course, people ask questions at the end. Just so you don't ask the same questions this year, I brought them. People ask how to upload 4 terabytes of data. That's always a problem. The answer last year was get a fast pipe, stream, do it as you generate it. This year we have a new alternative that is just sending me your hard drives. Google has this way now that if you have a lot of data, you want to upload it to the cloud, and it will take too long, you can just FedEx it overnight, and your data will be there the next day. How does it compare to other specific software? There is other software that allow you to analyze terabytes of data. And one way to look at this is that it doesn't compare. BigQuery is not software, BigQuery is a service. When you are using software, you have to make a lot of decisions. You have to decide what computers it will run on. You have to decide how much memory you want to use, how many hours it will be running, how will you orchestrate the whole thing. But at the end of the day, there are only two questions that matter. What is your data, and what questions do you want to ask from it? So what you really want to know is that. And BigQuery allows you to focus only in those two facets. The only two variables you have with BigQuery is what is your data and what the questions you ask, and that's also the pricing model it has. You pay for storage, you pay for queries. It doesn't matter with any other alternative, you will end up with the same two questions, but you have to solve a lot of questions beforehand. With BigQuery, everything else gets abstracted. And how to integrate Hadoop with BigQuery. Answer last year it was complicated. And I'm happy to announce that very soon, not today, but very soon we are releasing a very fast connector. So even when there are things that BigQuery might not do, the connection with Hadoop will be very fast, very easy, and maybe BigQuery will be the best way, the best place to store your data and connect it to other third-party software. But more on that, wait for that announcement. Now, let's go back to 2013. My talk for today, you saw the title, is about breaking the big data limit. It doesn't matter how much data this big data software can handle. They all have limitations. In the case of BigQuery, for example, we say that it can handle limitless data. When the legal team sees that, they get very nervous. They don't want me to say it can handle a limited data. But the truth is that so far, no one has reached that limit. No one knows what the limit is. So if you want, please test it. Please tell us that it didn't handle your data. I don't think you will be able to reach that limit. But there are other limitations. There are other ways to grow. So this database can grow unlimited in a taller way. But maybe there are other limitations. First, let me tell you what are the Google technologies. You've been asking me a lot about some of these. And maybe you already know, you saw yesterday's talk about the 3 stages of big data. Google, when Google started 15 years ago, none of this big data software was available. And most of this technology needed to be invented at the time. I'm very proud to say that it was people at Google that created all these technologies. You might recognize their MapReduce. MapReduce is what you might be able to use today as Hadoop, and that's amazing how it went from a little paper in 2004 to all the usage it's getting today. But there are more technologies, the Google File System that's also incorporated in today's big data technologies on how to store in distributed computers a lot of information. Bigtable, how to store key NoSQL data. That's where it all started. Most of these things, we are packaging them now, so you can use them too. MapReduce, as I was saying, is what Hadoop is now. Bigtable, you can use it at data store. Dremel. Dremel is the basis of what I'm talking today. Dremel now is packaged as BigQuery. You might have heard about the new technologies papers we're releasing, Spanner, Colossus. People are asking me a lot when I will be able to use it. The answer is they are not packaged as separate software. They are the backend our whole technology is running on. So yes, you have heard about F1. F1 is our internal replacement for how we were using MySQL at a very large scale. And you will see this product, and you are seeing this product packaged as our cloud database offerings. I will show you a little more about that later. So yes, here is our cloud offerings. They are all running in the cloud. There are different databases. Each one has limitations. When you choose which one to use, you have to be aware of them. If you are still at the MySQL level, if you are using MySQL, we have that offering. I wouldn't call that big data, but it's data. It's important to handle. It's important to have an SQL usage for relational databases. And we have our managed solution. Check it out, the Google Cloud SQL. As you move into big data and move into levels of data that MySQL can handle, we have our NoSQL database, the Google Cloud Data Store, that you might have seen it first in Google App Engine. Who here has used Google App Engine? Thank you. I hope you have enjoyed the data store. You can also store objects in the cloud, files, big things that not necessarily have a structure. You can use Google Cloud Storage for that. And what I'm presenting today, BigQuery, the analytical database. This is not a transactional database. This is not a sub-second database. This is a database where you can leave huge amounts of data and have answers in seconds. If other solutions, if what you are doing today is taking you minutes, hours, or maybe days, you might be very impressed of how BigQuery can solve the same questions in mere seconds. Next slide. Yes. So coming back to limitations, every tool has its limitations. These were some of BigQuery limitations a year ago. This database could handle unlimited data, but what about its width? How wide could this database be? Last year, this was the answer. Each row in BigQuery could handle only 64 kilobytes of data. 64 kilobytes data can be a lot. When I was young, that was a whole computer. So don't look at it as a small number. But today, we've heard that people wanted more. They didn't want 1,000 columns. They wanted 10,000 columns. And today, the limit is 1 megabyte for CSV, 20 megabytes for JSON. That really enables a whole different use case. Handling a database that has 10,000 columns might be hard, but it might be the best solution sometimes. So that's one limitation we have broken this year. There are more limitations. Maybe you can see them when you see Dremel's architecture. I don't know if someone can see what's a very apparent bottleneck here. Any answers? Anyone can see? Yes? The mixer 0, yes. As you can see here, everything, I don't see my light. Yes, I see my light. Everything starts in the distributed storage. That is very fast to read. There is a parallel architecture to read all this data in parallel very quickly. But as data gets aggregated, it all ends up in one mixer. That mixer has the job of getting all the data together. That mixer has a job, for example, if you are sorting it, to sort it. So, and this gave us a limitation. You can read unlimited data, but your limitation was you might at most output 128 megabytes of compressed data. 128 megs of compressed data is a lot. But you talked to us, you told us your use case. And for you, sometimes it was important to have more than that. Why? For example, you have a terabyte or a 3 terabytes data or a petabyte table, and you want to transform it. And you don't want to do it 128 megs at a time. You want to do the whole of it. And how do we solve this? We take this architecture, and we get rid of the mixer 0. This is a way where we can read all the data in parallel, and we just leave the data. We transform it, but we don't take the step of mixing it. You may see a problem here too. Anyone wants to guess why would this wouldn't work? You had a great answer yet? So this looks like a great idea, but there is a reason it doesn't work, is that if I'm reading in parallel a lot of data, and I want, for example, to group it, I need someone to mix it at the end state. If I want to have my data group by customer ID, I need to group all the customers somewhere. So if I read it in parallel, I write it in parallel, I will never do that state. So we had to solve that problem too. So this is a BigQuery query. Here people want to contribute, in this case, the Wikipedia logs. They want to have how much change has an individual contributor contributed to Wikipedia. And group by had this limitation where everything had to be run in Mixer 0. Mixer 0 has limited memory, so we could only group by a limited amount of data. We could only have group bys for low cardinality groups. How do we fix that? We added the it keyword, group it by contributor ID, and instead of grouping on Mixer 0, we take that architecture and we add a shuffling state where we divide all the data before giving it to the leaf. It's a little hard to explain, or maybe it's easy. Let's see how this goes. Let's say you have only two groups. You have the reds and the green. What the shufflers will do here is read all the data, and before passing them to the next state, they will just divide them. Reds go this way, greens go this way. This creates it's very simple, and they will never mix up in the tree, so we can do this in parallel. We don't have to care about grouping them later. Doing this shuffling process is you can see it's very expensive. That's why we are showing there that it's quadratic, because basically you have n machines talking to n machines. The network bandwidth you need to do that, it's huge, but we are able to solve it, and now you are able to group by any cardinality using this keyword. So now we can do more than small groups, we can do any cardinality of groups thanks to this shuffling step. And thanks to this shuffling step, we can also fix the largest results problem, where we have the shufflers that can shuffle according to these groups, and then the leaves process information. It doesn't have to be mixed again. It goes back to distributed storage. Now you can do unlimited outputs. Let's see, 8 megabyte joins. We have tables, we have very big tables, and sometimes we want to join them with more information. And we had this limit where joins, you could only do a join where one table was small, an 8 megabyte of compressed data table. Why did we do that? Because we copied all the information to every leaf. So we did joins by copying 8 megs of data to every leaf, and then each leaf was able to do that. What's the solution a year after? We are using the shufflers. We are doing the joins at the shuffling stage. What you can do now, you can join very big tables. You can join, for example, I don't know, all your sales, day by day, hour by hour. You can join them with a weather database that reflects the weather along all the country, all the world. And you can see how your sales vary by how the weather was yesterday, how the weather was today. There are many interesting use cases there. Try them out. Join it is a new keyword. Let's continue. There are more limitations. Not every limitation comes from this. architecture. So let's forget for a minute about the shufflers. Let's think what other things we could improve here. And here we have the distributed storage. That's very fast to read, but we have this limitation of how much data you can put in. How long does it take to put data inside your database? And we have this limit of 1,000 load jobs per day. That's a lot. 1,000 is a big number, but it still made you wait at least 90 seconds before doing a load job. For some people that was perfect, but some people want to solve the real-time use case. Some people have a constant stream of data coming in. So what did the engineering team do? They removed that limitation. There is still that batch way of inputting data, but if you really need the real time, now you're able to stream today up to 100 rows per second, and you are able to read that data in real time. Once you send the data to BigQuery, it's ready to be analyzed. That's great news for people that have to solve the real-time case. Just to put an example, we did this for Google I/O. We put all around the Moscone Center 500 sensors. We have Julie Steele today, coming later today. We work with her. That was a very fun project. And at the moment, we were able, for Google I/O, we were only able to input data the old way. Now when we do these installations, we are getting a constant stream of data in. Other limitations, what do we have here? The mixer 0. We don't want to get rid of mixer 0. Mixer 0 is important, for example, when we want to sort stuff. And we can make it smarter. How can we make it smarter? We can add new functions. I don't know how many of you have used the analytic or window functions that are available in many databases. Any usage? A little, yeah. It's interesting that they are very cool. You can do a lot of interesting things with them, but people don't really use them. I hope that from them being in BigQuery, people are more aware of how can they use it. For example, we will have a workshop later today, Bitcoin. I hope you can attend it too. We will go deeper into how to run queries. And in this case, I was asking this question. Who are the top 5 sellers, or in this case, earners of Bitcoins for every day? How can you solve that with SQL? It's not easy with normal SQL. You can group by how much they have sold. You can see how much they did per day. But when you want to sort, you want to sort with the data partition by day. And window functions, analytic functions are great for that. In this case, you can see a normal SQL of how I'm grouping and summing up what's the total for each contributor. I'm grouping them by day. And then in a subquery, I'm asking, OK, BigQuery, now give me a row number, rank them, how, partition them by day, and partition them by day. So when we have the whole solution, it will give a number for every row. 1, 2, 3, 4, 5, 6, and it will start again every time the day changes. So then with another subquery, I'm able to ask it, give me all of them where the rank is less or equal than 5. So now I have what the top 5 for each day. And I can ask further questions. In this case, I'm counting how many times each one of them have been one of the top earners. So in this case, we can see that things are very distributed. This is over 40 days of data. In the top 5, there has only been one guy that has been repeated 11 times. But if you go back to the position 11, that guy has only been on the top 5 only 2 times, and so on. Everyone else have been on the top 5 only once in these 40 days. I can go further with the window analytic functions. I can ask the percentage, this is the ratio to report function where I get SQL calculates the total, and I can ask, hey, tell me what percent does each one represent. Less limitations, more limits that we can break. We can make the leaves smarter too. What you have to remember about analytic functions is that they work at the final state. So they are limited by mixer 0, but they add us smarter ways to explore our data. Let's look at what we can do at the leaf level, so we can do it in parallel. We added the correlations. Correlations are an amazing way to get insights from data. I've been running some use cases. You can take them on YouTube. One, for example, is where we take 70 million flights around the United States, and we are looking at how delayed each of these flights was every day. We can average it per airport, so we get a time series for each airport. And we can look, hey, this airport, what's the most similar airport to it? How can you do that with SQL? You can ask for correlations. Hey, BigQuery, take all these timelines, give me a timeline for each airport, and tell me which ones are the most correlated. If you do a time displacement, if you move one of these time series by 1 day, you can get to, hey, for this airport, for New York, what's the best airport to predict what will happen tomorrow? And you get spatial relations. So for example, what happened today in New York is not as good to predict what will happen tomorrow as it's, for example, New Jersey, because the weather moves from one place to the other. With BigQuery, you can run an amazing number of combinations. Let's say I have, for example, 64,000 web pages. This is something I'm doing with Wikipedia. You want to compare the time series to the same web page to see which ones are correlated. That's 1 billion combinations. You can run that. We were doing that with the data sensing lab too. Here we are seeing two curves that they look similar. They are not the same, but the correlation is high. So you can discover things that are similar without them having to be exactly equal. So these are some of the limitations we removed this year. I'm really looking forward at what will happen next year. Those were only some of them. Pricing has got better. There are bigger quotas. The API is working much better with more alternatives. The web UI that you can go and ask queries for, it's getting smarter every day. We are getting more functions. So it's really, for me as a user, I really love using this product and looking forward at how it changes and what questions I can ask. For you, it's your turn now. I want you to upload data to BigQuery. I want you to share your data. I want you to participate. Upload is easy. Whatever your database is, you can get a CSV export. You can upload it to BigQuery. You can start asking questions. You can go to the web page any day. And you can ask questions that maybe no one has asked before. And there is a real power you feel at that moment. When you're taking raw data, you are getting answers in very few seconds, and you are learning that something that you might be the first guy or girl to ask it. You can share your data too. If you're doing a data challenge, if you are in the public government, if you have information that can be shared, once it's in BigQuery, it's very easy to set a bit where you want it to be public, where you want other people to be able to ask questions there. And once you do that, share with more people. Tell them that's available. Once you discover data, share your insights with more people. Tell them what your queries are. Let them go explore further. We have our local GDGs to participate. Andres runs this program. I had a great meeting with some of you. Some of you are here today. On Tuesday, it's great to be able to be a community, a local community, but you are also able to participate on the internet. I love Reddit. I have this BigQuery Reddit where I share whenever I get news that I want to share with you. I put them there. I hope you can put your news there too, comment, give me your insights. We have this specifically BigQuery site. It's in English, but I love the name, BigQueries. That's why it has that last name. And for questions, I will take questions now. But remember that we also have Stack Overflow. We are very active there. Our engineers and there. We are looking at the questions, not only to answer them, we are there to see what you want, what are your problems, how do you want this product to grow. And with that said, thank you for being here. Thank you for being awake or half awake. Please give me your questions and let's talk later. Let's share later our Bitcoin BigQuery workshop. Thank you.
Thank you, Felipe. Questions, anyone? Yeah, over there, no? Okay. We have this workshop later today, so we are going to see BigQuery in action with a challenging data set, which is conceptually a bit hard to understand. Yes, please, over here. By the way, if you didn't sign up to Google app, we can use Felipe's quota as long as we don't abuse it, and we are going to distribute the password, so you don't have to wait for the approval by Mountain View, which takes around 24 hours, something like that.
Yeah, it depends on Mountain View, but
right.
yes.
So, I mean, if anyone wants to join the workshop and has not benefited yet from the credits, please talk to us, and we will try to find a way. Mm-hmm. Yes.
Hello. By what I've read, Google BigQuery charges by query. Each query has a price, a tag price, and then you have to pay it. Do you have any flat model where you can query as much as you want?
That's a great question. The question is, what's the model we have for pricing? And you're right. The model is you pay 8 cents per gigabyte stored per month, and you pay per query. You have a free quota. Everyone can go and play with the free quota. For the workshop, that might be enough. If that's not enough, we will solve it somehow. But some people have been asking for a flat rate. We don't have that. I know it's important for people. At the same time, what I'm getting for our big users, big clients, once they start using BigQuery, they don't really care about pricing. They care about pricing, but it works really well for them compared to other flat models, because if they were to run their own clusters, it would be much more. Now, how it can work for you, how much are you expecting to pay, that's something that we can talk about. But if you keep your usage model focus on what you're doing, it's not really a big cost compared to if you had a flat rate, maybe you would be paying more. It all depends what your use case is. Do you have any special use case?
Actually, we are thinking about using our own custom solution, which doesn't work so great. We are thinking about moving to Amazon Redshift, which offers a flat rate, just because Google BigQuery doesn't. And our team of operations, they are making queries all the time, and they don't want to be charged by the query.
Exactly. Yeah, I would love to see the comparison.
Okay.
The pricing model is different. Now, what gives you the better price at the end of the month for the more analysis? At the end of the day, you want answers fast. For the same questions, what's the better pricing option for you? I would love to know that analysis.
Thank you.
Thank you.
Very well. Thank you very much, Felipe. We don't have time for much more.
Well, thank you very much. Thank you very much, Paradigma. Thank you much for being here.
Thanks a lot.